Hi guys, last video we did an analysis for a bar under tensile load using solid elements. Today we are going to look what exactly going to be the response if we use bar elements or truss elements. So we have created a model 2 here, and so quickly we'll go and create our part. So today we are not going to make a 3D, we'll rather go for a 2D planar, and under that we'll choose a wire base feature. We'll name it as bar wire, as it is just a uniform cross section. Bar will just need to create through wire, and let's fix it left hand, give it a dimension of 500 mm. It's 500. So our bar is ready using the wire elements. Bar is ready. Next step would be to give it property. We'll quickly create the steel material, elastic material, Young's modulus, elastic and isotropic 200,000 0.28. Material is ready. Now we have to create a section. So here is the basic difference. Last time we were using solid elements, so usually while defining the section you have to use the solid category, but now today we are doing it with bar or truss elements, so we have to use a beam based category, and then under that we will choose truss. Steel wire section. Cross sectional area, we need to define here what exactly is the cross sectional area. Our cross section is 100 cross 100, so let's 10,000 mm square. Let's quickly assign it to our bar. Done. Steel wire section, it is defined. Color is changed to green. Let's do meshing. We'll do a meshing of 20. Good enough. Okay, let's have a look. What is the element type? Element type we don't want for beam, we want it to be truss. Beam is required if there is out of plane loading, but here it is in plane, so just let's go for beam, oh sorry, truss, and let's quickly do a meshing of it. Mesh is ready. Next step would be to bring it to assembly module. Let's bring it assembly module, bar wire, it is coming there. Then what kind of analysis we want to do? We want to do is static analysis. Static, go for static, non-linear geometry off, we don't bother about that. This analysis, our model is ready, we just are to provide the loads. Let's provide the loads. So load of concentrated force on one end. Which end? Right end. Let's keep it right end. Doesn't really matter because it's a very simple problem. And as per the global coordinate system, we want the load to apply in first direction. 1000 kilonewton. Boundary condition, let's keep it encastered, although it doesn't really matter because for this kind of element, couple of degree freedoms, they don't have any meaning. You just have 3 degrees of freedom in 1 second and probably rotation about z. Our model is ready. Let's do now the analysis. I have already made a another model over here, so let's quickly put submit and see how does it work. Bar wire tension to compare it with the bar tension, which was 3D, and now we are doing with. So just to give you brief, what we are expecting is from this analysis, when we are applying a load of 1000 kilonewton on the right hand side and it is fixed on the other hand, we are expecting 1000 kilonewton here on the left hand side as the reaction force, and stress should be somewhere around 100 megapascal throughout the length of this particular bar, because it's a uniform cross section until unless it has cross section which is varying, or there is a stress a step in the cross section. So this is what we were expecting, but last time it was similar but not exactly 100 megapascal. There were values which were different. So let's have a look what is the result now. exactly what we were expecting, 100 megapascal, or in other words, that's von Mises. Let's have a look at S11. That's also 100 megapascal. Just to have a comparison, what we had obtained last time when we did using solid element, it was not exactly. So von Mises was somewhere around 104 megapascal at most of the locations, but it was 68 megapascal at the fixed end. Let's have a look what exactly was S33. Why SS33? Because here Z direction is the axial direction. That's why I'm looking at that. So here also there is some variation between um, free end and the fixed end. And the reason is very simple. When we are using solid elements, it does have Poisson ratio effect, although that is not the case when we are using the bar element or here the truss elements, because now when we are extending it to right direction, these particular elements at the fixed end where we have given encasted, they are not allowed to shrink their volume. That's the reason why there is a variation in the stress. I hope that clarifies. Thank you.